Hi, welcome to my Physics 2212 Lab 2 Charge Tape Revisit Lab Report. The goal of the lab is to using a different model, lines of charge model, revisit Lab 1 to approximate a more precise result, comparing it with Lab 1's point charge model. The results which I found is the electric force on tape B is 1.69 times 10 to the negative 3 newtons. The charge on tape B is 2.38 times 10 to the negative 8 coulomb volts. Then is the procedure. It's very similar to the lab 1. First, create a base tape. Second, prepare a U-tape. Third, put two thick books together with a small space between them. Then put one U-tape on it, put another U-tape under it, observe the interactions between them. For this lab, we need to make some key assumptions to make a more precise results. First, assume that each U-tape has the same net charge. Second, each U-tape's electrons are equally distributed. Third, ignore the L resistance. Fourth, assume my hands and other stuff don't contain any charge. Then let's move on formula and method. First, we will be using is Newton's second law. The acceleration of an object depends upon two variables: the net force acting on the object and the mass of the object. Second, electric force is exerted between any two charged objects. Third, Coulomb's law. Last, we will be using the superposition to find the total charge of the whole tape. Then is the data and the calculation. My data is showing the graph. Tape length is 0.2 meters, tape width is 0.02 meters, and the distance between two tapes is 0.042 meters, tape's weight is 0.00196 newtons, and the U-tape's charge is 1.073 times 10 to the negative 8 coulomb volts. The calculation is showing the slides. Here is a freeboard diagram. The U-tape B, which in the red, is on the top, and there is a small blue ball in the U-tape B, which is the point charger we use calculator, and there is a red big ball on the right of the U-tape B is the lines of charges we are calculating right now. Here's my grasp code. On top of the code are the constants which I declared. Next is the method I used to calculate the electric field. Then is the another method I used to calculate the lines of charges. Then at the bottom of the code is the two objects which I create for the two U-tapes. Here's the last portion of my code. On the top of the code is a nasty for loop to use the superposition concept to calculate the whole electric force. On the bottom of the code, I create two arrow objects representing the electric force and the gravitational force. Last, I use two print statement to print out my output. Here's the output of my code. The magnitude of electric force is 1.96 times 10 to the negative 3 newtons. The magnitude of the gravitational force is negative 1.96 times 10 to the negative 3 newtons. They are opposite, exactly opposite, and very precise. Next, I will talk about some errors. In this lab, we probably have some errors encountered. First, the inaccurate measure of the tape's length and width. Second, inaccurate measure the distance between two tapes. Third, when doing the suspended U-tape experiment, the two tapes might not completely balanced. Last, the electrons on my hand and other stuff could possibly affect the tape. Last but not least, for discussions, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experiment data to produce a point charge model to the value you got with your line charge model. For the point charge model, I got is 1.073 times 10 to the negative 8. For the line charge model, I got is 2.38 times 10 to the negative 8. They have 54.9% difference. Why do these estimates differ? Which value is more likely to be closer to the real value and why? In this lab, my model is lines of charge model. I separate the tape into 100 pieces and calculate each electric force due to tape A, then use the superposition to add them together. It is more precise and more close. Compared to the model 1, I just use the 1-point charge. The gravity force and the electric force will not be equal.